All right, folks, continuing with the review for test number 2 from review packet number 1, we're going to do questions 20, 21, and 22. Question 20 says, identify the following information for the function. This is 20, that's about here. F of x is equal to 3x to the fourth minus 10x to the third minus 17x squared plus 92x minus 84. And we want to identify the y-intercept. We want to identify the roots. We want to identify the degree, the lead coefficient. I'm just going to put LC. And then we want to know what the factors are and each factor's multiplicity. Multiplicity. Factors and multiplicity. Okay, I have the factors. So the y-intercept is really easy. We know that the y-intercept is the last number here. Now bear in mind, the y-intercept is a coordinate. It requires two numbers. Negative 84 is one of those numbers. The other number is 0. So do not, over here at y-intercept, do not just put negative 84. You have to put parenthesis 0, comma, negative 84. Okay, because that is a coordinate. That is the place where the graph is crossing the y-axis. It is crossing the y-axis at the point 0, negative 84. Now we're going to identify the lead coefficient. The lead coefficient is 3. We also want to identify the degree. The degree is right here. It's 4. Well, that was easy. So we only got two things left to do. Now to identify the factors, and then subsequently the roots, we are going to we're going to use the rational root theorem. So we're going to want to identify all of the factors of 84 and the factors of the lead coefficient 3. You can see that we're basically using the same numbers from the y-intercept and the lead coefficient. So the factors of 84 are, I know we got 1, 2, 3 is a factor, 4 goes into 84, 5 does not, 6 does, 6 goes into 84, 7 does not, oh yeah, sure does, 7 does, all right, yeah, because if you split this in half, it becomes 42, and 7 is a factor of 42, so 7, 8 does not, 9 does not, 10 does not, 11, 12, okay, so let's start dividing our numbers in. 7 goes into it, oh, 12 does, yeah, 7 times 12, that's what it is, so 12 is, and then 6 and 14, and then 4 and 21, and then 3 and, let's see here, 30, 60 plus 8, 28, and then 2 and 42, and 1 and 84. Now you're not going to need all of these, but I want to make sure that I show you the correct way to do the rational root theorem. Since you're not being graded on identifying the factors, you can just identify a few of them and check them as you go. You don't have to do the whole thing as you're going. All I care about is whether you get the correct numbers over there. So the factors of 3 are 1 and 3. So I know that I'm going to have plus or minus all these numbers. Plus or minus, 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 plus or minus. So let's just start testing out some of these numbers, shall we? I'm going to start with 1 and negative 1. So I'm going to put a 1 in the half box. I've got a 3, I've got a negative 10, I've got a negative 17, a 92, and a negative 84. Draw a line, put a 0, 3 plus 0 is 3, times 1 is 3, minus 10 is negative 7, times 1 is negative 7, minus 17 is negative 24, times 1 is negative 24, 92 minus 24 is 68, and 68 times 1 is 68, but we're not going to get a remainder of 0, so we know that 1 is not one of the, so we're going to try negative 1 now. 1 is not one of the zeros. So now we'll try negative 1. Put a 0 here, 3 and 0 is 3, times negative 1 is negative 3, minus 10 is negative 13, times negative 1 is 13, minus 17 is negative 4, times negative 1 is positive 4, 92 plus 4 is 96, times negative 1 is negative 96. That's not going to be a remainder of 0 either, so negative 1 is not. So not 0 and not positive 1, not negative 1. Moving on. We're going to try 2 and negative 2. Whoops, there we go. Put a 2 in here, draw our line, put a 0, 3 and 0 is 3, 3 times 2 is 6, minus 10 is negative 4, times 2 is negative 8, minus 17 is negative 25, times 2 is negative 50. 92 minus 50 is 42. 42 times 2 is 84, and 84 minus 84 is 0. So we got a remainder of 0. So we have found that one of our zeros, one of our x roots, one of our x-intercepts is going to be at x equals 2. So I'm going to put 2 comma 0. All right? And this now indicates that one of my factors is x minus 2. So under factors and multiplicity, I'm going to put x minus 2. Okay? Now, I'm going to try 2 again, because this factor may show up twice. So I got to do it again. So I'm going to bring down, but now I'm going to work with these numbers. I'm not working with the original numbers. I'm breaking the polynomial down piece by piece. So I'm going to put a 3, a negative 4, a negative 25, and a 42. Draw a line, put a 0. 3 plus 0 is 3, times 2 is 6, minus 4 is 2, times 2 is 4, negative 25 plus 4 is negative 21. Negative 21 times 2 is negative 42, plus 42, again, remainder of 0. And so that means that x minus 2, the factor x minus 2, it shows up twice. Now, it does not give me another root. Roots can only show up one time, but factors can show up more than once. So now I'm going to try 2 again, because there might be a third one, actually. So I'm going to use these numbers now, 3, 2, and negative 21. Put a 0 here. 3 plus 0 is 3, times 2 is 6, plus 2 is 8. 8 times 2 is 16, minus 21, not 0. So we're not. So there is not a third factor of x minus 2. So let's try negative 2 now. So put a 0 here. 3 plus 0 is 3, times negative 2 is negative 6, plus 2 is negative 4. Negative 4 times negative 2 is 8. This does not give us a remainder of 0. So negative 2 is not one of the roots. All right. So what's our next number there? 3, plus or minus 3. So put a 3 here. Then we'll do negative 3. 0, 3 plus 0 is 3. 3 times 3 is 9. Plus 2 is 11. 11 times 3 is 33. Does not give us a remainder of 0. So we're going to move on to negative 3. Draw a line. Put a 0. 3 plus 0 is 3. Times negative 3 is negative 9. Plus 2 is negative 7. Negative 7 times negative 3 is positive 21. Minus 21 is 0. We've got a remainder of 0. And that means that negative 3 is one of our roots. So I'll put negative 3 and 0 as the x-intercept. And then the factor that goes with negative 3 is x plus 3. And now, here's what I need you to notice. Look, now we're down to only 2 numbers down here. Once we're down to 2 numbers, we can stop doing synthetic division. These 2 numbers are our final factor. We put an x on this one, and we've got it. It's 3x minus 7. That's our factor. So here, we'll put 3x minus 7. But we also need the root that goes along with 3x minus 7. The way we get the root that goes with 3x minus 7 is we do 3x minus 7, set it equal to 0, and solve. Add 7, cancel. 3x equals 7, divide by 3, and x is equal to 7 over 3, 7/3. So under roots, we're going to put 7 over 3, comma 0, and we're done. That's it. We got our y-intercept, we've got our roots, we've got our degree, lead coefficient, the factors in the multiplicity, and we're done with question number 20. Let's go on to question number 21. So here we have question number 21. In this case, I give you the information you need. Now, there was an error on the packet. Instead of having 50, it says 05, but it should say 50. And nobody's really come to me yet to tell me about that error, but this is supposed to say 50 because 05 would not be a root. That would actually be a y-intercept. So let's go ahead and graph this. So the first thing we want to do is we want to plot all the roots, and we want to plot the y-intercept. The y-intercept is at 0 and 180, and I want to label that as 0, 180. I want to plot 3, 0. That's about right here, I guess. Put a 3, 0. Then I want to plot 5, 0, which is kind of over here to the right of that, 5, 0. Then I'm going to plot negative 1, 0 and negative 4, 0. So negative 1 is probably about right there, negative 1, 0. And then negative 4, 0 is about over here, negative 4 and 0. Once we've plotted all the points, now we can think about what is the graph going to look like. Well, the lead coefficient is the next thing we want to look at. Because the lead coefficient is negative, that means the right side of the graph is going to be pointing down. If the lead coefficient was positive, the right side of the graph would point up, but it's not, it's negative, so the right side is pointing down. Then we look to the degree. The degree is 5. That's an odd number. When the degree is even, that means the left side does the same thing as the right side. But here, the degree is odd. So the left side is going to go the opposite direction from the right side. So if the right side is going down, the left side is going to go up. So I'm going to put an up arrow here. Now, all we have to do now is thread through all the points and match this arrow up to this arrow. But here's the key. We have to be careful about the multiplicity. Remember, when the multiplicity is even, that means the graph does not cross over the x-axis. When the multiplicity is odd, then the graph does cross over the x-axis. So we're approaching -4 here, which is associated with the factor x plus 4, has a multiplicity of 1. That's odd, so we're going to cross over. So we're going to cross over here. Then we got to turn around and go to -1 here. And that's associated with x plus 1. Has a multiplicity of 1, so again we're going to cross over. So we're going to cross over. Then we want to go through our y-intercept here, so we're going to go through that point. Then we're going to go to the 3, 0. 3, 0, x-intercept of 3 is associated with the factor x minus 3. Here's x minus 3, and it's squared. It has a multiplicity of 2. So that means we are not going to cross over here. We're going to touch and turn away. Touch and turn, moving away. Then we're going to turn back around and aim for the 5. X minus 5 has a multiplicity of 1, so we're going to cross over. Then we're going to meet up with the arrow, and that is a rough sketch of the graph of the function that has these qualities. Okay? So that's question number 21. Now we're going to do 22, and we'll be done with the packet. Okay, here's question number 22. Question 22 just says, sketch the graph of this function. It doesn't even give you any of this stuff here. It just says, here's a function, sketch the graph. Well, in order to sketch that graph, I'm going to need to find these 5 pieces of information. So basically what we're doing in this question is we're doing question number 20 combined with question number 21. We're doing both of those skills in the same question. So I need to know what the y-intercept is. Well, we got a -60 on the end, so that means the y-intercept is 0 and -60. The degree, well, that's 4. The lead coefficient is a positive 3. Now we got to find the factors with their multiplicities, and we got to find the roots. So we got to do the rational root theorem on 60 and 3. So we're going to do, let's see here. Let's go over here. 60 has factors of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 15, 20, 30, and 60. And then 3 has factors 1 and 3. So we're going to do plus or minus 1, plus or minus 2, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, plus or minus 6. Then we'll go from there if we need them. Okay? So we'll do some synthetic division here. Let's go down here. I'll try 1. Nope, I can't do it there. I'm running out of space here. How much space do I have over here? A little bit? I'll do it right here. Let's make the graph a little bit smaller. So I'll do 1 here, and my numbers are 3, and -8, and -19, and 76, and -60. So let's see here. So I'll put a 0 here, bring down 3. 3 times 1 is 3. Minus 8 is -5. -5 times 1 is -5. Minus 19 is -24. Times 1 is -24. 76 minus 24 is 52. And 52 times 1 is 52. Minus 60 is not 0. So since it's not 0, 1 is not one of the roots. So let's try -1. Something weird going on there on the board. There we go. All right, let's put a -1 in. So then we've got 0, 3. 3 times -1 is -3. Minus 8 is -11. Times -1 is 11. Minus 19 is -8. Times -1 is 8. 76 plus 8 is 84. Times -1 is -84. Well, that's also not going to give us a remainder of 0. So then we are going to skip over that one. And we're going to move on to 2 and negative 2. 2, put a 0. 3 plus 0 is 3, times 2 is 6, minus 8 is negative 2, times 2 is negative 4, minus 19 is negative 23, times 2 is negative 46, plus 76 is positive 30, 30 times 2 is 60, and 60 minus 60 is 0. So we've got a remainder of 0, so we found our first factor, or our first root, which is positive 2. So over here in roots, we're going to put 2 comma 0. And under factors, we're going to put x minus 2. All right, now we're going to try 2 again because it might show up twice. And we're going to use these numbers now, a 3, a negative 2, a negative 23, and a 30. So put a 0. 3 plus 0 is 3, times 2 is 6. 6 minus 2 is 4, times 2 is 8. 8 minus 23 is negative 15. Negative 15 times 2 is negative 30, and sure enough, we get a remainder of 0 again. So that means there are 2 x minus 2's. All right, so 2 x minus 2's. Now, we're going to try 2 again, only on these numbers, to see if there's a third 2. So we've got a 3, we got a 4, we got a negative 15. Draw a line, put a 0. 3 plus 0 is 3, times 2 is 6. 6 plus 4 is 10. 10 times 2 is 20. Minus 15 is not 0, so we've exhausted the use of 2. That's all the x minus 2's that we're going to find. So let's try negative 2. And put a 0. 3 plus 0 is 3, times negative 2 is negative 6, plus 4 is negative 2. Negative 2 times negative 2 is 4. 4 plus negative 15 is not 0, so we're done with negative 2. All right, now let's try 3 and negative 3. So put a 3, put a 0. 3 times 3 is 9, plus 4 is 13. 13 times 3 is 39. Minus 15 is not 0. All right. Let's try negative 3. All right, put a 0. 3 plus 0 is 3, times negative 3 is negative 9. Plus 4 is negative 5. Negative 5 times negative 3 is 15. Minus 15 is 0. And so we found our next factor. Our 0 is negative 3 and 0, making the factor x plus 3. And because now we're down to only 2 numbers in our synthetic division at the bottom, that is our final factor, 3x minus 5. So here we'll put 3x minus 5. And we need the 0 that goes along with 3x minus 5. So we'll set 3x minus 5 equal to 0 to solve. Add 5, right? And we'll get cancel. 3x is equal to 5. Divide by 3, and x is equal to 5 over 3. So our root is 5 over 3 and 0. So we've got our roots. We've got all of our factors. See, we have 1, 2, 3, 4 factors. Degree of 4, so we've got them all. And now we can graph. We're going to plot our y-intercept and all of our roots. 0 and negative 60 is down here somewhere. 0 and negative 60. 2 and 0, that's about here. 2 and 0. Negative 3 and 0, that's about over here on the left side. Negative 3 and 0. And then 5/3. That's about the same thing as, 3 goes into 5 once. And so that's 1 and 2/3. That's right about here. It's really close to the 2. We'll put it right there. And we'll write 5 over 3, comma 0. So that's 5/3 and 0. So they're really close to each other, those two zeros. Now we're going to draw the graph. We need to know whether the right side is going up or down. And that's determined by the lead coefficient. The lead coefficient is positive, so that means the right side is going up. The degree is even, and that means the left side is going to do the same thing as the right side, which means point up on the left. Okay? So now we just need to connect, and we got to decide where to cross over and where to touch and turn. Okay? So negative 3, that's associated with x plus 3. Well, x plus 3 is a multiplicity of 1, so we're going to cross over at negative 3. Next thing coming along is the y-intercept, so we'll go through the y-intercept. And then this 5/3, that's associated with 3x minus 5. Well, that's the first power. multiplicity of 1, so we're going to cross over there. Then we're going to turn around. Then we're going to go back to the 2. The 2 is associated with x minus 2 with a multiplicity of 2. That's an even multiplicity, so we're going to touch and turn. So we're going to touch here, turn around, and there we go. And now we have, that's the sketch, a rough sketch of the graph. We have done everything here. And if you are capable of doing question number 22, you're capable of doing the entire test, because everything in the test are just skills that lead up to being able to do this. And let me tell you, there probably are not a lot of people in this world who are capable of doing this, but you are one of the people that are capable of doing this, okay? All right, well, that's it. There's another packet you can work on. I'm not going to do a video on that one, but the test is next class, and these two videos should help you get ready for it, so good luck.